It is called virtual images. Real images are the images which can be seen, which can be obtained by the real interception of the light rays on a screen. So on a screen, we can see the images. That is called real image. Virtual images means we can only draw the diagrams, but we cannot see. Clear?
Yes, sir.
Then we have to remember certain points. Real and virtual images are there. Reflection of light obeys two rules. You may be knowing the rules. What are the two rules?
I'm not admitting you.
Laws of
The
reflection.
incident
Yeah, the incident ray,
equal to
reflection ray, and normal.
and
Yeah, yeah,
angle of
you know all
incidence
these
equal
things.
to angle of reflection.
Yeah, enough.
Angle of incidence to
Okay.
angle of reflection.
Then
Angle
concave
of
mirrors
reflection
form
is equal
real
to
and
angle.
as well as virtual images, whereas convex mirror forms virtual images only. That also you will be knowing. Okay, now we move on to the next one. Mirrors and lenses are used in our daily life. In many situations, we use mirrors as well as lenses. Okay, now, so in this session, we will be focusing on all these things, refraction. In brief, we will touch all these things and we will see the power of a lens. See this one. This is called refraction of light, bending of a light ray. When it is straight, when this one is straight, nothing happens. Now it is straight, nothing happens. But when it is moving to one side, it is bending. So the change in the direction of light when it passes from one medium to another obliquely. What is this statement called? Obliquely. What is the meaning of this obliquely? Meaning of this oblique.
Medium.
One medium to another medium.
Which causes
Yeah, light ray when it passes from one medium to another at an angle, not perpendicular, at an angle, not equal to 90 degree. Then only it will get refracted, it will get bending. Okay, na? So
can I say the meaning of obliquely?
Yeah, at an angle, you see this one. This light ray is coming like this. It is bending.
Indirect, sir.
Yeah, this angle, it is called. It is bending. It is hitting the surface obliquely. It is hitting the surface not perpendicular. If it is perpendicular, nothing happens. See, if it is perpendicular, no bending. Okay. So this diagram, you can see the angle of incidence and angle of refraction. Shall we move on?
Yes, sir.
Someone
Sir,
Yeah.
why does the light bend, sir, when it
Light-
travels from one medium to another?
Why does the light bend when it is moving from one medium to another medium? We are coming into that. So that's what we took the topic refraction. Why it bends? We will discuss it in the due course of the class. All right?
Yes.
So 1 minute.
Yeah. Any more questions? Or I'll explain now itself because it takes some other. Okay, so when light ray comes from one medium to another medium, see this one. This is air. Air is having lesser optical density. That means particles in air will be lesser. When it is entering into, for example, water or anything like that, water is a medium which is having larger density than compared to air. So larger density means large number of particles will be there. So the light, this one, it will have to hit the different particles inside the medium. When it is hitting the different particles inside the medium, it will have a reduction, it will have a decrease in the velocity of light. As the velocity of light decreases, there will be a change in the path of light. Am I clear to you?
Yes, sir.
Yes, sir.
But I didn't get any answer from the boy who raised the question. Who raised the question?
Sir.
Is it clear to you?
Yes, sir.
Okay, fine. Don't be passive listeners. Interact with some questions, some doubts. All right. So we move on to the next one. So it is a medium. Yes, it is a medium through which light travels. Medium is a transparent substance through which the light travels. There are two different types of medium: optically rarer medium or optically denser medium. Rarer medium means speed of light will be more. Rarer means lesser number of particles in the medium. Okay, optically denser means more number of particles in the medium. So that is rarer medium and a denser medium. So glass is optically denser medium than air and water. See,
And let's do it, please. Why does light change direction?
Rekha, please mute yourself.
Discuss that in detail. The change in direction of light occurs because of the change in the speed of light in that medium. When light moves through a medium, it will change its speed. The speed may either increase
So
or
does
decrease.
water refraction occur same?
Note that when we say that the speed will increase, it does not mean
someone's mic is on. Please mute your mic.
it's valid against the speed of light refraction. When the light is entering into the
Sir,
glass,
could you
it travels at a lesser speed than it moves, and when it goes from glass to air, its speed increases. So it's because of this change in speed that the direction of light changes. But what if the light is entering perpendicular to the surface of the glass? Will its speed change? Yes, its speed will change. However, it does not bend this time. Yes, the refracted ray propagates in the same direction as the incident ray. Talking about the case when light enters at an angle, there is one more observation that we can make. Observe this part of the refraction. Observe the incident and refracted rays. We notice that the refracted ray is more towards the normal than the incident ray. When the light rays enter the glass from air, it bends, and it bends towards the normal. And from this refraction, we can see that when the light ray again enters the air, it bends away from the normal. So we can say that when the light travels from an optically rarer medium to an optically denser medium, it bends towards normal. And when the light travels from an optically denser medium to an optically rarer medium, it bends away from the normal. What do we mean by optically rarer and denser mediums, by the way? An optical medium is a medium through which light can propagate. Since both air and glass are transparent, light can pass through them. So, both of them are optical mediums. What about rarer and denser? If the refractive medium is optically rarer compared to the incident medium, then the speed of light in it will be greater. And when the refractive medium is optically denser compared to the incident medium, the speed of light in it will be lesser. Note that in both cases, we are comparing the speed of light with the speed of light in the incident medium. So what do we understand by this? How can we summarize it? When light is traveling from an optically rarer medium to an optically denser medium, its speed will decrease and it will bend towards the normal. Whereas when the light is traveling from an optically denser medium to an optically rarer medium, its speed will increase and it will bend away from the normal. Now that it's clear, I want you to understand another concept. Now, instead of a glass slab, we have water, and also suppose that the ray of light is incident in the same direction. We can see that this angle is the same in both the cases. So will the refracted ray in this case travel in this direction only? In other words, will the angle of refraction be the same in both cases? No, the angle of refraction will be different in this case. In fact, the angle of refraction here is greater than the previous one. So what can we infer? We can say that the refraction of a light ray depends on the material medium on which light is incident. Yes, light rays will be refracted by different amounts in different materials. But wait, I have a couple of questions for you. Talking about the case when light enters at an angle, how does the change in speed result in the change in direction of light? And why does this perpendicular ray not change its direction after refraction? I know you must be curious to know the answers. However, we'll understand this in the next video. It's really interesting. Make sure you watch it.
Okay.
Sir, I got confused. When does the light bend away from the normal?
Which kind of confusion?
Sir, when does the light bend away from the normal when it travels one medium to another?
Bend away from the normal. So it is if it is entering. One second.
One medium to another.
Yeah,
Question I left you with.
this one, isn't it?
Sir, back.
Yeah, it is coming into one medium, that is a rarer to denser. If it is entering from a rarer medium to denser medium, that is optically less density to optically more density, it will come towards the normal. And if it is from optically higher density to optically lower density, it will move away from the normal.
Okay,
Clear?
thank you, sir.
Clear?
Yes, sir. Thank you, sir.
Okay, you know why it is coming towards the normal and why it is going away from the normal?
No, sir.
Sir,
Okay,
because of the speed.
Yeah, because of the reduction in speed. Light will have lesser velocity in a optically denser medium and more velocity in optically rarer medium. Okay, now?
Yes, sir.
Fine. We will move on to the next one. See this one, how it is bending. It is from rarer to denser. It is bending towards the normal. So there are certain rules of refraction. We will go in a faster way in this one. We have to focus or concentrate more on the power of a lens. So when it is coming from a rarer medium to denser medium, it bends towards the normal. That is rule number 1. And it is went from a denser to rarer medium. See, it is entering from a denser medium to a rarer medium. It will bend away from the normal. This is the normal. So rarer to denser, moving towards the normal. Denser to rarer, moving away from the normal.
Sir, after critical angle, it will reflect.
Yeah, that is different one. That is a special case. These are the general rules of refraction. Okay, now these are the laws of refraction. You may be knowing the laws of refraction, incident ray, refracted ray, and the normal. They all lie in the same plane. Ratio of sine of angle of incidence to the sine of angle of refraction is a constant. And that constant is called, what is the name of that constant?
Snell's law.
Yeah, this law is Snell's law, that's okay. What is the name given to that constant?
Refractive index.
Yeah, refractive index. What is the unit of refractive index? Do anyone remember the unit of refractive index? Anyone remember the unit of refractive index? See this one in the numerator, we have sine I, and here again we have sine R. So it is a ratio, sine I divided by sine R, it is a ratio. So normally ratios, they have any unit?
No, sir.
Yeah, refractive index is a ratio only. It is only a ratio. So it will not have any kind of units. Okay?
Sir, it is the ratio with the speed of vacuum.
No, speed of light in vacuum to the speed of light in that medium. Speed of light in vacuum to speed of light in that medium. So it is a ratio of velocities also.
Okay, sir.
Agreed?
Yes, sir.
Okay, fine. We move on and let us see more on the refractive index. Refractive index of glass with respect to air. So it will be speed of light in air by speed of light in glass. Speed of light in air is C and speed of light in glass is V. Now refractive index of air with respect to glass, inverse of this one. So this one will be N2 by N1. N2 is speed of light in air and N1 is speed of light in glass. So it comes to C by V. Similarly, refractive index of air with respect to glass is V by C. Okay, na?
Yes, sir.
Okay, fine. Let's move on. Yeah, please.
As will zero, no sir, 0 unit.
No, I'm not hearing you properly. Can you repeat the question once again?
Sir, the refractive index of glass will be 0 unit, no sir.
Glass will not be 0 unit. How it will be 0? Because speed of light in air is not 0, speed of light in glass is also not 0. then how the refractive index of glass with respect to air will be 0? It will not be 0. Okay? Okay, we move on to the next one. This is the refraction through a glass slab. Light ray is coming, it will bend towards the normal because it is entering from a rarer medium to a denser medium, move towards the normal. Now here it is entering from a denser medium to a rarer medium, so it is moving away from the normal. So there is a lateral displacement from the normal direction. There is a lateral displacement. Okay. Now here refraction is happening or not in the first slab? In the first slab,
No,
refraction is
sir.
happening or not?
No, sir.
No,
No.
sir.
What is the reason? What is the reason?
Because it is not
It is
in
entering normally on a boundary. When the light incident normally on a boundary, refraction will not take place. Refraction will take place only when light incident obliquely at an interface.
Sir, it depends on the angle, sir.
Yeah, right. Depends on the angle. And see this one, this block. Can you identify anything in this block?
Yes, sir. The incident ray is slant, sir.
Yeah, incident ray is not changing its direction. There is no bending,
Sir,
there is no
both are on
deviation,
same
nothing is
medium.
there. And what is the reason for
Angle of
that?
reflection is
What is the
0,
reason for
sir.
that?
Sir, the density is equal to the
Yeah, optical density or the refractive index of both the media are equal. The refractive index of both the medium are equal. So that's why there is no bending. Bending is not taking place. So refraction will take place only when under these two conditions. Light ray should travel from a one medium to another medium with a difference in refractive index. And another one is it should incident obliquely at an interface. Then see this question. A ray of light traveling in air enters obliquely into water. Air,
Towards the normal, sir.
does the light ray bend towards the normal or away from the normal?
Towards the normal.
Towards the normal.
Anyone with an answer away from the normal? No, nobody is there. Okay, fine. Bends towards the normal. That is rarer medium to a denser medium, light bends towards the normal. Now, second question, see this question. Take a pen and paper. Take a pen and paper. See this. Tell me the answer.
Sir, maybe 2 lakh.
2 lakh. No, 2 lakh in the sense that there is no such terminology in physics.
So 2 into 10 to the power of 8 meter per second.
Yeah, very good, excellent. So it is like this 2 into 10 power 8 meter per second. So this is speed of light in vacuum by speed of light in medium. Okay, so you can calculate quickly and you can tell that speed of light in glass is 2 into 10 power 8 meter per second. Very good, well done. Now, rules for obtaining images by lenses. Rule number 1, if it is coming parallel to the principal axis, it will pass through the focal point. Agreed? This is the case with convex lens, and in the case of a concave lens, it appears to be coming from a particular point on the principal axis.
Sir, the convex lens and concave mirror same properties.
Convex lens and concave mirror, same? No, not same properties. Mirrors are always, they will give only reflection, not refraction. Okay, now we are discussing about only refraction, not reflection. Fine. The next rule, if it is passing through the focus, it will become parallel to the principal axis. And in the case of a concave lens, if it is entering into the focal point, it becomes parallel to the principal axis. Okay, so this is the third rule, that is through the optic center. Through the optic center, it will pass without any deviation. So these are the converging lenses. What do you mean by the word converging? Converging.
All the light
Sir,
rays.
it will focus all the light rays to a point.
Okay, it will converge all the light rays. Okay.
Will intersect every point.
Okay, so that is
Focusing on a single
all these
point.
light rays to be converged to a particular point, isn't it?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Try these rules parallel to the principal axis is passing through this one. All the three lines in the same diagram. Clear?
Yes, sir.
Okay, fine. Now see the formation of images in convex lenses in brief, in quick manner. This is a convex lens. Object is placed between the focal point and optic center. Then the image will be on the same side, virtual and erect, smaller than the object. And second thing is object is at the focus, then the image will be at infinity, real inverted, highly magnified or highly enlarged. Then the third one is between f and 2f. I think you might have cleared all these concepts, isn't it?
Yes, sir.
Okay, okay,
Yes, sir.
Yes, sir.
Yes, sir.
just I'm just brushing it up, that's all.
Yes.
Okay, observe. Then this one 2f, again the image will be formed at 2f itself with same size, real inverted. Then beyond 2f it will be formed between f and 2f. Then object is at infinity. If the object is at infinity,
But focus.
then it will be formed at the focal point. See this animation. If it is coming from a faraway point towards the focal point, no? Up to focal point, the image will be magnified. Then beyond focal point, it forms a virtual image. This is a beautiful illustration because it is coming from, object is coming from infinity towards the focal point. See the size of the image changes. Clear? Shall we move on?
Yes, sir.
Okay, fine. Okay, now this is another one. When we move object from one location or increase or decrease the size of object, how the size of image is varied, just to check. When we increase the size of object, the size of image also will be increased. When we move from infinity to 2f, when the size increases.
Sir, doubt, sir.
Yeah, sure.
So the 2f is center of curvature, right?
Yeah, correct.
Thank you.
So this is this one. Then yes.
Where should an object be placed so that that real and inverted image of the same size could be obtained in convex lens?
I didn't get it properly. Once again.
Sir, where should we place an object so that real and inverted image are same size?
Where we have to place an object?
Fo- Focal length. 2f, ma'am.
No, I'm not able to hear you properly. So what you mean I am not getting?
Sir, there is an internet problem.
Internal?
Sir, where should we place an object so that real and inverted image formed at same size? At 2f, ma'am. Center of 2f.
Real and inverted images. So that is real and inverted means
At 2f.
no, that is common. Same size image. 2f is same size image. When you keep an object at 2f, see at 2f, if you keep an object at 2f, it gives a it gives an image at a 2f. If you this one, if you keep it at a 2f, the image will be again at 2f on the other side. The image will have same size, everything will be same except that it will be inverted. And in that, what is your doubt? See this one.
Yes, her doubt.
Okay, na? Okay or not?
Okay, sir.
All right. Okay. We move on to the next one. In the case of lenses, concave lenses, so image at infinity, image will be formed at, so object at infinity, image will be formed at focus. Between optic center and infinity, it will be between F and O. We will see another, this one. And I have a very different question. In almost all animations and almost all announcements, almost all railway stations and everywhere, we hear only female voice through the public addressing system. What may be the reason for that? In all railway stations, that announcements are there, it is made in female voice. In airports, announcement is made in female voice. In almost all animations, good animations, we hear female voice only. What is the reason?
Sir, their voice will be clear.
Clear in the sense that?
Sir, pitch, their voice pitch is high.
Yeah, excellent. The female
High
voice is
pitch.
having high frequency. Frequency will be more. High frequency. High frequency means high energy. Means it is able to travel longer distances. So if the announcement is made with a female voice, that voice or that voice from that public addressing system will be able to travel longer distances without any kind of energy loss. That is the reason why they prefer female voice. All right. Now you see this one.
Bends towards the normal, and when it again enters air, it bends away from the normal. Will the concave lens behave in the same way as the convex lens? Will the rays converge after refracting from a concave lens? If the rays from a point object are incident on a concave lens, then after refraction, they do not converge at a single point. These refracted rays diverge. It means they go away from each other. But wait, since they do not intersect at a common point, does that mean no image is formed? Well, the image is formed. If we were to extend all these rays backward, they all meet at this point. The virtual image is formed at this point. So this is a pattern by which concave lens refracts rays of light. It diverges all the light coming from a point. Hence, it's called a diverging lens. Now let's look at both the lenses side by side. So the convex lens converges all the light rays from a point object, and the concave lens diverges all the light rays from a point object. But usually our objects are big and not just a single point. So let's use an arrow to denote an object. We can take points on the arrow and find out the image for each point. Finally, we join all the image points together to get the complete image. This is a real and inverted image. This is the image formed for an object when a convex lens is used. Are the object and the image of the same size? What will happen if I change the position of the object? Will the position of the image change? Will the size of the image change? In order to know the answers to these questions, keep watching our future videos.
Okay, so this one, concave lens. In the case of concave lens, when we move towards this one, see the changes happening there. Okay, fine. The sign conventions in brief, just brush it up. These are the sign conventions.
So doubt.
Yeah, sure, please, raise.
There is convex lens and concave mirror have same properties.
Convex lens and concave mirror.
Yes, sir.
Same properties in the sense that these are entirely different. The lens is based on the laws of refraction, whereas mirror is based on the laws of reflection. Okay, lens is having two surfaces and the mirror is having only one surface. But the image formation means convex lens forms real as well as virtual image. Concave mirror also forms real as well as virtual image. In that sense, we can say that they are similar in the formation of images.
Thank you,
Whereas
sir.
one more problem is there. Lens always forms an image. If it is a real image, lens always forms a real image on the other side of the lens only, not on the same side. Whereas a mirror forms an image. If it is a real image, mirror forms an image on the same side. These are the differences and similarities between convex lens and concave mirror. Clear?
Yes, sir. Thank you, sir.
Okay, fine.
So the parallel lines never intersect, but when the object is placed in focus, the parallel rays go. Then the image form at infinity. How does it form?
Parallel rays never intersect, but
Then
we
how does the image forms?
we assume that they intersect at infinity, but we cannot go to infinity and check whether it is there or not. The real image is there or not. Okay, now it is only a hypothetical idea.
Excuse me, sir.
Yeah, please.
Sir, we have so many lights passing through an image, right, to form an image. Sorry, there will
We
be so
have so
many
many. Pardon,
light
so
rays
many.
passing through the object. Light rays passing through the object
Okay.
to form the image, right?
Okay.
Sir, but while we are writing the diagrams and all stuff, we only take some particular rays. So 1, 2, or 3 maximum rays.
Okay. We have only three rules. Okay, now to represent that three rules, we take only 3 light rays.
So can we, sir, can we take the all rays which actually?
Okay, we can take all the light rays. We can take all the light rays and draw the same diagram. But to represent the 3 rules, whether we followed the 3 rules or not, we pick up the 3 light rays.
Sir, then how can we sir, if I'm learning this ray diagrams for the first time, sir, how
Okay.
can we take those rays actually like this itself? Like it has a particular way, right, to go there. So how can we take the particular way to go,
Particular
on the object?
light ray.
Yes, sir. Sir, the way it goes.
We have 3 rules of formation of light images.
Yes, sir.
Okay, the first one is if a light ray parallel to the principal axis, it will bend. It will go through the focal point. Okay, now so we take a parallel light ray.
Okay, sir.
In the second, like that, representing the 3 rules, we pick up 3 or 4 different light rays and we mark it.
Okay, sir. Got it. Thank you.
Now, this is the consequences of new Cartesian sign conventions. The magnification, listen, the magnification, it is size of image to size of object. Now, these are the different formulas in that. Listen, lens formula is minus 1 by u plus 1 by v equals 1 by f. Magnification is v by u. And m is positive if the image is virtual and direct. M is negative if the image is real and inverted. So these are the statements which we make after seeing the images. Okay, now let us see the power of a lens. So power is represented as inverse of focal length. So focal length to be expressed in meters. Okay, so if the focal length is 10 centimeter, it should be converted into meter. 10 centimeter equals 0.1 meter. So the power will be 1 by f. 1 by f means 1 by 0.1. So it will be 10 diopter like that.
So can you hit the last line? Please write it down.
Yeah, sure. Okay. Now, it is actually the converging capacity or diverging capacity of a lens. How much the light ray is converged, how much degree means how it is getting converged to a particular point, that is measured by the power of a lens. The amount of convergence or divergence it creates, that is called the power of a lens. Okay, so it is inversely proportional to the focal length. So it is having large focal length means the light will converge at a faraway point from the lens. If it is having a lesser focal length, then the light will converge to a nearby point to the lens. So that is why P equals 1 by f. What does it mean about the shape of the lens? Can anyone answer? If it is a fatty lens, that means thicker lens, power will be lesser or more?
It will be more, sir.
Power will be more. And if it is a thin lens, power
Less
will
than.
be less. Correct.
Yes, sir.
Correct. Okay, next one. The power of a lens is calculated by using this one. It is reciprocal of its focal length in meters. F equals 1 by P. The unit of power is diopter, represented by capital D. Obviously, the power of convex lens is positive as well as the power of a concave lens is negative. For more clarity, let us see this video.
All of your life. We use different types of lenses in our daily life to correct different types of vision, just like myopia, hypermetropia, and all those things. And also we use different types of mirrors. And most of the time we come across with a situation to define the power of a lens. So you often get confused also, what is the power of a lens and how it is related to the focal length of the lens. See this one, this is the convex lens. See the curvature of this convex lens. And this is again another convex lens. See the curvature and how this curvature is related with power of a lens, and again how the power of a lens is related to the focal length of the lens. So let's see the power of a lens. So let's begin. Power of a lens. We know that when a parallel beam of light incident or strike on the surface of a convex lens, it converges at a point. Let's see. A convex lens, a parallel beam of light strike on one surface of a convex lens, it will converge at a point, and this point is called the focal point. See, this is the focal point, and we know that this length is the focal. So this is the focal point, and this length is the focal. अब ये देखने की ये लेंस इतना मोटा है, अब हमारे पास इतना मोटा नहीं, थोड़ा सा स्लिम लेंस है. Thickness is somewhat lesser when compared to the first convex lens. ये मोटा है, ये मोटा नहीं है. ये देखिए अभी क्या हो, the same parallel beam is coming, वही parallel beam इसके ऊपर भी आते हैं. अभी तो इसका convergence होगा.
OS is okay or not?
Sir, can you turn volume up?
Okay, sir.
Okay, fine.
ज्यादा दूर वही पॉइंट में नहीं कंट्रोल होते हैं, इधर कंट्रोल. ये देखिए वो जो पैरेलल बीम इसके ऊपर आते हैं, दोनों एक ही साइज का पैरेलल बीम आते हैं. पहला लेंस मोटा है, मोटा लेंस में नजदीक में कंट्रोल हो जाते हैं. और अभी ये जो लेंस है, तीन लेंस में ये भी दूर जाके कंट्रोल होता है. ये देखिए अभी इसका फोकल लेंथ बहुत ज्यादा है, इसका फोकल लेंथ बहुत कम है. अब ये आप ही बताइए कि इसमें ये दोनों लेंस में किसका पावर ज्यादा है? Obviously, the power of this one is greater. Here the power is greater. Here the power is lesser. So here we will get a relation between the power and focal length. Power and focal length are inversely proportional. Inversely proportional. It is very clear from these two diagrams. If the focal length is lesser, power is greater, and if the focal length is larger, power is lesser. So we can precisely define power as the converging capacity of a lens. अगर power ज़्यादा है तो very close to that lens is getting converged, and power को कम है तो ज़्यादा दूर जाके converge. So power is the converging capacity of the lens. So power, we have seen that power is inversely proportional to the focal length. So we can define power as the inverse of focal length. And we know that focal length is a length. So how do we measure focal length? Focal length is to be measured in centimeters. Normally we measure in centimeters. So we have to convert that focal length into meters. So that is 10/100 of a meter. So that is equal to 0.1 meter. Then what will be the power of that lens? Power equals 1 by 0.1, that is equal to 10 diopter. It is represented by the letter capital D, diopter. So the power of the lens is represented by the letter capital D, diopter is the unit of power. Now if it is that, what will be the focal length of a lens whose power is 1 diopter? If the power of the lens is 1 diopter, what will be its focal length? अगर power 1 diopter है, इसका focal length कितना होगा? देखिए, focal length will be equal to 1 by power, that is 1 by 1. ये मिलते हमें 1 meter. इसका मतलब ये होता है कि एक diopter का मीनिंग ऐसा होता है कि एक diopter power वाले लेंस हमारे पास है, उसका कन्वर्जेंस होगा, उसका इमेज हमें मिलेंगे 1 मीटर आगे. Simply, very simple. It is very simple. एक मीटर में अगर हमें इमेज मिलते हैं तो उसका पावर होगा 1. फिर एक बात और है, हमारे पास डिफरेंट टाइप्स ऑफ लेंसेज है. कॉन्वेक्स है, कॉन्केव है, प्लानो कॉन्वेक्स है, प्लानो कॉन्केव है. अगर कॉन्वेक्स है तो पावर इज पॉजिटिव, कॉन्केव है तो पावर इज नेगेटिव. दिस इज अगेन पॉजिटिव, दिस इज अगेन नेगेटिव. So this is the basic nature of power. Once again, let me remind you, power is the inverse of focal length, and that focal length must be expressed in meters. So we are in a position, we are in a very confident state to identify whether a lens is convex or concave. If the power is plus, that is positive, हमें पता चलेगा कि वो convex lens है. अगर power negative है, हमें पता चलेगा कि वो concave है. कोई प्रॉब्लम नहीं. अभी प्रॉब्लम आने वाला है, हमारे पास एक लेंस नहीं, ज्यादा लेंस है. लेंसेज का एक कॉम्बिनेशन है. अगर हमारे पास लेंसेज का एक कॉम्बिनेशन है, उसको इन कॉन्टैक्ट अरेंज करने पे उसका कॉम्बिनेशन का पावर कितना होता है, वो कैसे मालूम पड़े. देखिए, ये एक कॉन्वेक्स लेंस है, ये दूसरा कॉन्वेक्स लेंस है. दे आर इन कॉन्टैक्ट. इसका पावर है P1, इसका पावर है P, इसका इफेक्टिव पावर कितना होगा? देख लीजिए ये पैरेलल बीम आते हैं, ये एक तरह कन्वर्ट होते हैं इधर और दूसरा कन्वर्टिंग होगा दूसरा लेंस के ऊपर, तो पूरे ये इधर आ जाते हैं। This is the focal point of the combination. दो convergence होते हैं, एक convergence, first convergence is offered by the first lens, and again it is getting converged because of the presence of the second. अभी इसका इफेक्टिव पावर कितना है? इफेक्टिव पावर होगा P1 प्लस P2। देखिए इसका पावर अगर दो डायोप्टर है प्लस दो डायोप्टर, it will be equal to 4 lenses. So when we add lenses together, the effective power also will be getting added. एक और ट्रिक है इधर, देखिए हमारे पास एक कॉन्वेक्स लेंस है और दूसरा एक कॉन्केव लेंस। कॉन्वेक्स लेंस P1 का पावर है 2 डायोप्टर, obviously it will be plus 2 डायोप्टर। इसका पावर है P2 minus 2 डायोप्टर। अब इसका कॉम्बिनेशन का पावर कितना होगा? देखिए P equals P1 plus P2, that is 2, that is plus 2 plus or minus 2, it will be equal to 0. अब आप ही बताइए ये लेंस कैसे कन्वर्ट करेगा? ये कन्वर्ट करेगा या नहीं करेगा? देखिए इसका पावर 0, अगर एक लेंस का पावर 0 है तो कैसे कन्वर्ट करेगा? Lens will not act like a lens, it will act like a sheet of glass. Conversion होगा, this is, we imagine that it is air, and if it is not air, it will have a lesser power and it will refract at a distant place. If this is the case of film. ठीक है? So the refracting capacity of a lens depends upon the power of the lens as well as the medium in which it is being kept. Once again, the refracting capacity of the lens is called the power. So its power depends upon the nature of the lens, whether it is convex or concave, it depends upon the medium in which it is being kept. अगर हवा में है तो मैक्सिमम पावर दे देगा, अगर हवा में नहीं है कुछ मीडियम है तो उसका पावर कम होगा, वो कर रहे हैं ज़्यादा। So now we are in a comfortable position to identify a lens whether it is convex or concave, and we are also in a comfortable position to say that what kind of lens is prescribed by a doctor for our defects of vision. ह्यूमन आई में डिफेक्ट होते हैं, मायोपिया एंड हाइपरमेट्रोपिया डिफेक्ट होते हैं, तो इसे रेक्टिफाई करने के लिए हम डॉक्टर के पास जा रहे हैं। So next time when you meet the doctor and when prescribe a lens like plus 1.5 diopter, you will be in a position to understand what kind of lens it is and what kind of defect you are having in your eye. Okay? Thank you.
All right.
Yes, sir.
Hello. Anyone there?
Yes, sir.
Yes, sir.
So, many of you may be having spectacles, and if you have a spectacle and you have a specific power for your spectacle, now you are in a position to identify which kind of spectacle you have, whether it is convex lens or concave lens or whatever it is. All right. See this one. Many optical instruments, they consist of a number of lenses. Instead of a single lens, they have a number of lenses. These number of lenses are combined to increase the magnification and sharpness of the image. The net power will be the sum of individual power. See, here it is a convex lens with a power of plus 4 diopter, and here it is a concave lens with a power of minus 10 diopter. The resultant power is minus 6 diopter. We take the sum of individual powers. Okay? We will add all the powers together and we will get the resultant power of this one. See this one. Here the focal length is 10 centimeter. Centimeter means the power is 1 by 0.1, it is 10 diopter. Here it is 20 centimeter, so 1 by 0.2, it is minus 5 diopter because it is a concave lens. Okay, we move on. Uses of lenses, where we are using the lenses. Lenses are used in camera, even in our eye, we have a lens in binoculars, then microscopes, then there's telescopes. Then the most important use of the lens is the spectacles. We have learned this much: the laws of refraction, image formation in a lens obeys certain rules. Then, most importantly, lens formula as well as magnification. Any questions? Any query?
So, video of your explanation, can we get it in YouTube?
Yeah. The entire this class, entire this online class will be recorded and it will be shared. YouTube also it is there in my channel. You can find it in my
So, your
channel.
channel name?
I'll give the address. Don't worry. Anyway, this class it will be recorded and it will be shared to you once the vacation is over.
Yes, sir. This class will
Let
be
us try this question.
uploaded on YouTube, Vigyan Jyoti Hyderabad. So you can view it there.
Please repeat it once again, madam.
The recording of the class will be uploaded, sir, on YouTube today. So the students can view your video.
Yeah, it will be recorded and uploaded in YouTube and you can view it. Okay. So nothing to worry.
Sir,
Then let us try these questions one by one.
sir, what is the power of lens which is present in our eyes?
What is the power of lens which is present in our eyes?
Yes, sir.
Is it same question? So it depends on the focal length. It depends on the focal length. So what is the size of your eyeball? It differs from person to person. Normally, it is a small eyeball. It is not that much bulky or heavy or whatever it is. It's a small one. Normally, the focal length will be, I think, 3 to 4 centimeter maximum. Depending on that, each one will have a different eyeball, no?
Yes, sir.
Okay, it depends on the person's health, and if he is using the spectacles and all, it will be slightly different.
Okay,
Normally
sir.
it will be under 3 to 4 centimeters focal length, and you can calculate the power of a lens. And if you are using spectacles and all, it will be different.
Yes, sir. Thank you, sir.
Try these questions. Try these questions. Can you see it?
Yes,
Yes,
sir.
sir.
Okay.
Yes, sir.
Who is that?
Yes, sir.
Okay, sir. We understand.
Okay, fine. This is a question of board exam. Which kind of lens you prefer while reading small letters found in a dictionary?
Okay, sir.
Which,
Okay, sir.
which type of lens you have to use? Lens with more power or less power?
More power?
More
Yeah,
power.
convex lens or concave lens?
Convex lens.
Convex lens or concave
Sir,
lens?
Concave lens. Concave
use
lens
the
is
Convex
sufficient.
lens.
power lens.
No,
Sir,
no.
we
More
will use
power
more power
convex
lens.
lens we have to use. More power means lesser focal length. So a convex lens of focal length 5 centimeter we have to use. There's different types of questions are there. The type of mirror used in the following situation: headlight of a car,
Convex.
concave mirror,
Concave mirror, sir. Concave mirror.
Concave mirror, sir. Concave mirror. Concave mirror. Convex.
right.
Concave.
Rear view mirror of a vehicle, solar furnace, and all everything uses concave mirror.
Concave, convex, concave.
Rear view mirror
mirror is convex.
Yeah, in the sorry, in the case of a side view, rear view mirror of a vehicle, we use convex mirror because it gives diminished images, diminished direct images. Now, this is another typical question. One half of a convex lens is covered with black paper. Will this lens produce a complete image of the object? What do you think?
Yes, sir.
It produces
Yes,
a
sir.
complete image. Good.
Yes, sir.
Right. See this one. Upper half is covered. Upper half of the lens is covered. Still, it forms complete image.
Sir.
Lower half is covered with black paint. Again, it forms complete image. Okay, so try to solve as many questions as you can from the CBSE textbook as well as other reference materials. Solving large number of questions will increase your efficiency and you will get good score in the board examinations. And if you are interested in doing assignments, there is an assignment for you. Okay.
Yes, I understand it. Sir, we can't see the questions clearly.
Oh, it's very small, it seems.
Yes, it is too big, sir. Yes, yes, sir. Okay.
Can you do it? Parallel rays of
Yes,
light
sir.
emerging a convex lens. Always converge it.
Principal focus.
Principal focus.
Yeah, principal focus. Good, very good. SI unit of power of a lens is
Diopter.
diopter. One diopter is the power of a lens of
Yes, sir,
focal
we
length.
can that.
By
One
hand.
diopter is the power of a lens of focal length.
1/10.
1/10.
10.
What is the correct answer for this one? One diopter is the power of a lens of focal length.
Sugar.
100 centimeter, 100 centimeter. That is actually 1 meter. If it is in centimeter, it should be 100 centimeter.
100
Visible
centimeters.
microscope uses convex lens.
100
So
Reciprocal.
what
centimeters.
are
100 centimeters.
Yeah.
biconvex lens?
Biconvex lens means both the sides are convex.
Biconcave.
Biconcave means both the sides are concave. Plano-convex means one side is plane and other side is convex.
Okay.
The power of a convex lens of focal length is 50 centimeter. How much it will be?
Plus 2D.
What is the answer to question number 47?
2D.
Plus 2D, sir.
Plus 2D.
Plus 2D. Plus 2D. Okay. The focal length of a lens whose power is minus 1.5D.
Plus 1.5 meters.
Sir,
Minus
Minus
1.5D is the power. What will be the focal length?
minus 1.5 meter.
Minus 1.5 meter.
sir, I think inverted, sir.
Pardon?
Plus 1.5.
No, if the power is negative, the focal length also will be negative only.
So minus
6.5.
6.66 centimeters.
Yeah,
So
minus
minus 1.5.
no, not
Sir,
minus 1.
49th question answer is inverted, I think.
Yeah, minus 66.66. Now question number 49. Real images formed by single convex lenses are always, if it is
Inverted.
real image, it will be inverted.
Invert.
Yeah, correct. The least distance of distinct vision.
25 centimeters.
25
25
centimeters.
25 centimeters.
Convex lens has a focal length of 20 centimeter. Its power in diopter.
0.5.
0.5.
2, sir.
0.5.
0.5.
Focal length is 20 centimeter. You have to convert centimeter into meter. Then you have to take the inverse.
0.2 meters.
0.2.
0.5.
0.2.
0.2, sir.
0.2.
Sir, 0.2, sir.
How it comes to
0.5.
0.2?
No, sir.
Its focal length will be 0.2 centimeter. Its power
0.5.
is 1 by 0.2 centimeter. It will be 5.
0.5.
Okay.
Yes, sir.
All right. The object is placed before a concave lens. The image formed is
Sorry.
right. Right. Then two thin lenses of power +5 and -2 are placed in contact with each other. Focal length of the combination
-3 meters.
-3.
+3 is the resultant power. Remember, +3 is the resultant power. Focal length will be inverse of +3. That is 1 by 3. 1 by 3 is 0.33 meter. Okay.
0.33 meters.
Yeah,
0.
0.33. Plus or minus?
Plus, sir.
Plus, plus. Okay.
Sir.
Good, good. Very good, very good. A glass, see the 69th question. Glass lens is immersed in water. How is the power of lens affected?
Refraction.
Refract. Refractive index.
Change in direction of the
No, no, it will decrease
Refractive
or increase.
index.
Power of a lens will decrease or increase.
Decrease.
decrease.
Decrease. It will decrease. It will decrease.
Decrease.
Okay, fine, fine, fine. Okay, so the 78th question. Convergent lens of power 8 diopter is combined with a divergent lens of power -10 diopter. Calculate the focal length of the combination.
-0.1.
Yeah, it will be -2. 1 by -2 is 0.5 centimeter. Okay, so like that, as many questions as you can. Solve as many questions as you can. That will increase your efficiency. And
Sir, can you keep the summary slide? We will write it.
pardon?
Can you keep the summary slide? We will write it down.
Yeah, sure, sure, sure. Okay.
Thank you. We will write.
Sir,
Yeah.
the difference between the mirror and lens is generally the lens refracts and mirror reflects. Then even though the convex lens and concave mirror properties are from both equal.
No, we cannot compare lenses and mirrors in the same frame. One is entirely depending upon refraction as well as in two media and all these things. Whereas in the case of mirror, only one media is involved, and it shows the property of reflection. Okay, now.
Yes, sir. Then apart from that, what is the difference between both of them?
I'm not able to hear you properly. Talk little louder.
Sir, apart from the reflection and diffraction of both the lens and mirror, what is the difference between both of them?
What is the difference between?
Both the mirror and lens, apart from the reflection and refraction.
Okay, the difference between. So in the case of lenses, we use lenses in different situations, like where we need real images as well as virtual images. And lenses forms images, and the images will be little lesser brighter because it undergoes refraction. Whereas in the case of mirrors, images will be more brighter because it is based on the principle of reflection. Because in the case of mirrors, about 90% of light will get reflected, so images will be more bright. Lenses are thicker, mirrors are a little bit thinner. Lenses are not having any coating, mirrors are having coating on one side. So those are the differences.
Okay, sir. Thank you, sir.
Okay.
Excuse me, sir.
Okay, fine, fine, fine. Okay, then I hope you enjoyed the session.
Yes, sir.
Yes, sir.
Yes, sir.
All right.
Yes,
Thank you. Thank you. Thank you.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you. Thank you, sir.
Thank you, sir.
And
thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Bye, sir.
Bye, guys.